No award. So, as recommended, I have a pre-written solution right here. Like all my notes are right here. Very hard. Just like I can do this. This is about as good. And so, the first thing you're going to do, which I've already done, is you're going to go to Stat, Edit, L1, L2, and enter the according values, which are given here on the sheet. And then from there, you're going to go to Stat, Calc. Whichever one you want to do, I have pre-put them in and saved them to different y variables so I can go through that as we talk. So for the first one, that is a linear regression right here. If when we enter that into the calculator, we get 5.714 for A, 28.286 for B, and the R squared is 0.895, which is very bad because it's below 0.9. And so that gives us our equation of f of x equals 5.714x plus 28.286. As we move on to the next one, the quadratic, we do the same thing and we are left with a equals negative 0.428 x squared plus 13.447x plus 4.643, and the R squared value is 0.976. When we go to the exponential, that is A is equivalent to 31.813 times times, oh my, this is not working, times 1.095 to the x, and our R squared value is 0.742, which is very bad. For the quadratic, the R squared is 0.976, which is very good. Not the best, could be better. As we come here, we get to logarithmic. For logarithmic, we get A is equivalent to negative 1.312 plus B, which is equivalent to 40.949 ln of x. And the R squared value for this one is 0.991, which is the best one. It is the closest to one. The closer to one, the better. That means it is closer to one, the better. One is a best fit. That is a coefficient of determination into which data best fits the model. We want to be as close to one as we can get. And as we move on to the sine, these last two are where they different, sine and logistic. For sine, we get A is equivalent to 2 279,872.221 times sine of B, which will come to 28.206 x plus C, which is equivalent to 1.292. I'm going to double check on my calculator. Yep, 1.292 parentheses minus D, which is equivalent to 269,109.907. 269. Oh, I can rewrite that better. 269.106.907. And then when we get to logistic, we get 110.593 over 1 plus 5.005 E to the negative 0.359x. And the r squared for that one is 0.965. And for sine, it is 0.977. The two that are different, I'm going to begin sharing my screen now. We go to Desmos, as we see here. All are the same, but these last two. For these last two, we get two different values for logistic and sine. For sine, Desmos shows a more accurate shift and arrows for manually fitting and visually adjusting the curve, so therefore Desmos is better for sine. For logistic, Desmos does not have a built-in logistic regression, which we see here. This is a different equation than the one we have on the calculator. So it's bet you have to enter the formula manually. On the TI-84, it is better for getting exact parameters, and since Desmos cannot do it accurately, the TI-84 is the best option for this one. The R squared value, as mentioned earlier, is a coefficient of determination. It's to which data best fits the model. The closer to one you are, the better. If you have one, you have a perfect fit. And so, based off this information, logarithmic is the best model type with an R squared value of 0.991. This is Noah Ward, dated on June 1st at 11:18 a.m. Arizona Standard Time. All work is shown here and will be uploaded